Last video we looked at the different particles that actually make up atoms, which are subatomic particles. And we remember that protons and neutrons, they're found in the nucleus of the atom, which is in the middle, and electrons fly around the outside of the nucleus at the speed of light. You can imagine that they're flying in a cloud. They're moving so fast. So the main idea in this video is that the different subatomic particles have different masses. So what we're going to do is compare the three subatomic particles again and have a look at how we can work out the mass of whole atoms. So here are our subatomic particles. We have protons, neutrons, and electrons. And remember, we learnt that two of the particles, protons and electrons, they have a charge, an electric charge. So we can compare the charge of each of these. Remember that protons, they have a positive charge. You can remember P for positive. So protons are positive. Neutrons, they get their name because they're neutral, so they have no charge. And electrons, remember, they're the negatively charged particles. So overall, atoms have no charge in total. So we can see this atom here. This is an atom of nitrogen. Nitrogen here, we have 7 protons. And we also have 7 electrons. And in the nucleus, we've got 7 neutrons as well. And because we have 7 protons, which gives us positive 7 charge, and 7 electrons, that gives us negative 7 charge, we have the same charge, so they balance. So we can remember that every atom is neutral overall. This can change sometimes, but we'll learn about that in later videos. So that's the charge of the different subatomic particles. And now we'll compare the mass. So just from the pictures, we can see protons and neutrons, these are the biggest of the particles, and electrons are absolutely tiny, like we mentioned in the last video. And a good way to think of it is protons and neutrons are so much bigger, it's like comparing elephants with ants. So electrons basically weigh nothing compared to protons and neutrons. So when we actually look at their masses, we can basically say electrons weigh nothing at all. We can say 0 mass. And protons and neutrons, we give them a mass of 1 each, because they're pretty much equal in mass. The units that we're using aren't really relevant at the moment, so we'll just give them numbers for now. So when we start looking at different atoms now and different elements, there's a special way of writing an element which shows all the information about the mass and about the charge. And this is called the atomic symbol, which we've seen before when we first learnt about elements. So here's the atomic symbol of nitrogen. Remember that nitrogen had 7 protons. If we go back up, it has 7 protons in the nucleus and 7 neutrons. And if we have a look at the atomic symbol of nitrogen, the number at the bottom left, this is called the atomic number. And that tells us the number of protons in that particular element. So every nitrogen atom will always have 7 protons. And it's the atomic number that tells us what type of element it is. Next, at the top left, this is called the mass number. And this is talking about how much does each atom of nitrogen weigh, using our basic masses that we talked about. So for nitrogen, there are 7 protons, and each proton has a mass of 1, and 7 neutrons as well. And each neutron has a mass of 1 as well. So we can easily add that up, and that gives us our mass number of 14 here. So the mass number, that tells us the number of protons plus the neutrons. And in other words, that's how much nitrogen atoms weigh, plus neutrons. And here's a general way of writing atomic symbols. Where we have Z, that's the symbol we use for atomic number. That's just a generic way of saying atomic number. And A is the symbol we use for atomic mass. Sorry, for the mass number. And X is just the atomic symbol of whatever element we're looking at. So the symbol of that element. So let's look at a different element again, and we'll practice writing the atomic symbol out properly. So here's a bigger atom now, and actually if we counted all the protons, neutrons and electrons, we have 19 protons. We've also got 19 neutrons in the nucleus. And we've got 19 electrons as well. Because the electrons always equals the number of protons. So that means if we look on the periodic table and we find the element that has 19 protons, we find this is the element potassium. Potassium is a really important element for living things. We need to use it in all our cells for lots of different jobs. It has the symbol K, and that means the atomic number we'll put at the bottom, 19, and the mass number, we just add the protons and the neutrons, so we have 38. So there's our atomic symbol for potassium.